If you can recall from previous recordings, when we tried to access an element of an array which was outside of the array bounds, our application threw an unhandled exception and it crashed. Indexed out of range exception is one of many exceptions that might occur in the program runtime. Other common examples might be a divide by zero exception if you try to divide by zero, or a null reference exception if we try to operate on an object which is a null reference. If we know that something like this could happen in our application, for example, the user's input might cause an exception, we can protect ourselves from the program crash with a try-catch statement. When an exception is thrown in the try block, the runtime will look for a catch block in which we can handle that exception. The syntax for the try-catch block is following. First, with the try keyword, we specify the block of code that might throw an exception, and then following that block of code we need a catch keyword, in which we can specify what kind of exception we want to catch and handle. Code from the catch block is executed only when exception is caught. The exception type is the base one, meaning that this catch expression would catch any expression that would occur in our program. But for example, we could narrow this catch expression just to catch index out of range exception. Then in this case, any other exceptions would cause our program to crash. What is also important is that we could have multiple catch blocks for a single try statement. Let's add another catch block with the base expression type. Now our try-catch block will work in the following way. The execution will go down the try block, and if some exception occurred in the try block, the runtime will look through all of our catch blocks, from the top one to the bottom one. If the exception type matches the type that we are trying to catch, the execution will be moved to that catch block, and once it is finished, it will not try to search for other catch block, meaning that it will exit from the try-catch statement. To see how it behaves, I will add a couple of console write-line statements and run the program in a debug mode. So let's add a console write-line inside of the try-catch block, and another one after our program will throw an exception, and a console write-line inside of the index out of range exception catch block, a similar one in the general exception catch block, and one console write-line outside of the try-catch block. Let's start the program and go line by line. There's the first console write-line invocation. Then we try to access an element with an index equal to 4, which throws an exception, and we didn't execute the second console write-line inside of the try block. Instead, now we are looking for a catch block which will match the exception. The statement catch index out of range exception matches that exception, so we go inside its block of code and execute the console write-line. And after it is completed, we are not looking anymore for the catch blocks, and there is the console write-line outside of try-catch. If that exception would be different than the index out of range exception, we would skip the first catch and end up in the second one. However, keep in mind that if we don't catch the exception in any catch statement, our program will still crash. One more addition to the try-catch block is a finally statement that might occur after all of the catch statements. Code from the finally statement will always be executed regardless if there's an exception in the try block or not. So it is the ideal place to do some cleaning up, for example, closing an open file or closing a connection to some database. Let's add a finally block to our example, and a console write-line cleanup inside. Now the cleanup message will be displayed always, regardless if there's some exception or not.